Hi everyone, this is Chloe, and today we're going to be discussing Nyquist plots and Bode plots. So for our first example, we're going to go over this Nyquist plot with the transfer function already in the Laplace space right here, k times s plus 10 over s times s squared plus 3s plus 50. And this has already been transcribed into the plot below, which will always be given to us. And as you can see, this plot does a little loop-de-loop and goes this way, so the frequency increases like that. And we want to determine the ultimate controller gain, but before we do that, we want to make sure that our system is stable and then determine how we can get the ultimate controller gain to be at the edge of stability. So we're going to add this -1 to our graph, and as you can see, this point lies outside of our graph, which is enclosed, and since this is not enclosed by our Nyquist plot, we know that our system is stable. And just to see the controller gain response, we can notice that as k decreases, this entire shape will contract and get much smaller and thus go away from the s equals -1. So as k gets smaller, it will continue to be stable. However, when we increase k, this entire shape will expand and get closer and closer to this s equals -1. So now we can determine our ultimate controller gain, which is KCU, and that's equal to 1 over gamma, and we know that this point right here is negative gamma 0, where our Nyquist plot crosses the real axis, so that's equal to 1 over 0.047, which is equal to 21.27, and that's all. So now we're going to move to a Bode plot. So the first step is to start at -180 degrees on our phase angle diagram, and we'll just draw a horizontal line across until it intersects this arc, and then this is where we are at our crossover frequency. So at the crossover frequency, we are allowed to jump to the amplitude ratio graph, and then this is how we determine our critical amplitude ratio, which is 0.4 for this graph. So to determine our ultimate controller gain, we take 1 over our critical amplitude ratio, which is 1 over 0.4 in our case, which is equal to 2.5. And then to find our ultimate period, we take 2 pi over the crossover frequency, which is equal to 2 pi over 5. Which we found here, and then that is equal to about 1.3. So now that we have determined our ultimate critical gain, our ultimate pyramid, our crossover frequency, we can now translate this to a neutral Nyquist plot. So on the gain neutral case where Kc equals 1, this would be our graph, and this would be AR, and that would be equal to 0.4. However, if we were at our ultimate critical gain, our plot would look more like this, and it would intercept that -1 right there, and our CU would be equal to 2.5, like we determined from the Bode plot. Sorry that my spiral is not the most perfect, but you get the idea. And then from this, we can again see that when ARC is less than 1, we're in a stable environment. However, as soon as it's greater than 1, we are unstable. And that is all for my video. Thank you.